In 2024, the United States military budget exceeded a staggering $800 billion, which is more than the combined budgets of the next 9 largest militaries in the world. Given this immense financial power, it should come as no surprise that the U.S. possesses some of the most advanced and expensive war machines on the planet. Take, for example, the U.S. Navy's latest aircraft carrier, the USS Gerald R. Ford, which carries a jaw-dropping price tag of $13.3 billion. Despite being commissioned 5 years ago, the state-of-the-art vessel is still not fully battle-ready, underscoring just how complex and costly these military projects can be. The Ford class is just the beginning of a larger trend in military technology. For instance, the U.S. Air Force's F-35 fighter jet program is projected to cost a staggering $1.7 trillion. Yet this groundbreaking stealth jet has faced numerous setbacks. Just recently, the Air Force had to ground its entire fleet due to faulty ejection seats, a small problem, but one that highlights the ongoing challenges in maintaining such sophisticated machinery. These are just some of the advanced war machines that the U.S. is using in various combat zones, such as the ongoing conflict in Ukraine, where high-tech weaponry like Javelin anti-tank missiles, howitzer artillery, and California-made Switchblade drones are being deployed. But what exactly does it take to build and maintain these colossal machines of war? The true cost of U.S. military technology extends far beyond the initial price tags, with hidden costs and delays mounting at every turn. Let's dive deeper into one of the most iconic examples, the USS Gerald R. Ford aircraft carrier. The Ford is the first ship in a new class of aircraft carriers designed to revolutionize naval power. It boasts a range of cutting-edge technologies intended to improve firepower and reduce crew size, which should theoretically save billions of dollars over its 50-year service life. However, the ship's construction has been marred by delays and budget overruns. The cost of building the USS Ford nearly doubled from $6.4 billion to $10 billion due to delays, with each new technology adding more unforeseen expenses. One of the most critical technologies aboard the Ford is its advanced weapons elevator system. These elevators are vital for transporting munitions from the ship's depths to the flight deck, ensuring that aircraft are rearmed efficiently. This system is a far cry from older, more hazardous methods used on previous carriers. However, this new system has been so complex that it took years to get certified, with the last elevator only being approved in December 2021. The Ford is also a testbed for more than 24 new technologies, each designed to enhance the carrier's effectiveness. However, as retired Navy Captain Tal Manville points out, introducing so many new innovations at once was a critical mistake. The ship's original construction timeline was pushed back multiple times, leading to a snowball effect that increased the cost. In 2017, the Navy took delivery of the ship, even though not all systems were operational, just to meet the year's budget requirements. The Ford's advanced technologies include an electromagnetic aircraft launch system, EMALS, which replaces the steam-driven catapults used on older carriers. This new system uses linear induction motors, similar to the technology behind high-speed maglev trains, to launch aircraft. While EMALS is more efficient and requires less maintenance, it came at a significant cost. Research and design alone cost over $1 billion, and installing the system on the Ford ended up being more than double the initial estimate. Moreover, the electromagnetic launch system also promises to be gentler on aircraft, extending their lifespan and enabling a wider variety of planes to use the carrier. However, even as the Ford is being built, some unforeseen challenges remain. For instance, the new launch system is not yet compatible with the latest F-35 stealth fighter, meaning the Ford will need a retrofit to accommodate this advanced aircraft at an additional cost of $315 million. The construction of the Ford has also been affected by political pressures and the shifting priorities of U.S. defense policy. Over the course of 2 decades, 5 different U.S. presidents had a hand in the ship's design and development. The Department of Defense's push to integrate too many new technologies at once, while trying to meet political and budgetary deadlines, significantly increase costs and prolong the timeline for completion. At its core, the Ford is an attempt to modernize the U.S. Navy's supercarrier fleet, which currently operates 10 carriers, one short of the legally mandated 11 due to the delays surrounding the Ford. The U.S. Navy's dominance at sea is critical, especially considering that the U.S. is one of only two nations, the other being China, with such an extensive fleet of aircraft carriers. The Ford and its planned successors are meant to ensure U.S. military superiority for decades to come, extending well into the 22nd century. However, while the Ford represents a technological leap forward, its construction has revealed the immense complexity and risks involved in developing such advanced military hardware. With more than 5,000 shipbuilders working 49 million hours on the project, 7 times the number of hours needed to build the Empire State Building, the Ford is both a feat of engineering and a cautionary tale about the costs of innovation. Despite the delays and spiraling costs, the Ford's impact on naval aviation will be profound. The integration of new technologies like the EMALS and advanced arresting gear, which allows planes to land with greater ease, will shape the future of naval warfare. But these advancements come with a heavy price tag, both in terms of dollars and time. Another technological marvel in the U.S. military arsenal is the F-35 Lightning II, a revolutionary stealth fighter that is intended to replace several older models, including the F-16 and the Harrier. The F-35 is designed to meet the needs of multiple branches of the U.S. military, including the Air Force, Navy, and Marines, but this has led to significant challenges. The F-35 is actually 3 different aircraft rolled into one: the F-35A for the Air Force, the F-35B for the Marines, with vertical takeoff and landing capabilities, and the F-35C for the Navy, designed to operate from aircraft carriers. The F-35 program has faced massive cost overruns and delays. The total cost of the program is expected to reach $1.7 trillion, making it the most expensive weapon system in U.S. history. The cost of purchasing the aircraft alone is estimated at $400 billion, but when factoring in the costs of development, testing, maintenance, and operations over the aircraft's lifetime, the bill could skyrocket. The F-35's operating costs are particularly high, with each flying hour costing around $35,000, almost 60% more than an older F-16. Despite these issues, the F-35 has proven to be a powerful asset in combat. It has been used in airstrikes against ISIS in Iraq and Syria, and is widely considered a game-changer in terms of stealth, sensor fusion, and battlefield awareness. But critics argue that the high operating costs make the F-35 an unsustainable investment in the long run. With over 500 F-35s already in service and plans to build nearly 2,000 more, the program is one of the most ambitious and controversial military projects ever undertaken. The F-35's development has also been plagued by design issues. Initially intended to be a one-size-fits-all solution, the F-35 had to be redesigned multiple times to meet the unique needs of each branch of the military. These redesigns resulted in significant delays and cost overruns. The F-35B, which was intended for the Marines, was overweight due to the need to incorporate vertical landing capabilities, while the F-35C for the Navy had to be modified to withstand the harsh conditions aboard aircraft carriers. While the F-35 has proven its worth in combat, the program is far from perfect. A decade and a half after its first flight, the F-35 still suffers from over 600 known problems, mostly related to software and hardware issues. These ongoing issues have led to rising maintenance costs, with estimates showing a 15% increase in sustainment costs from 2018 to 2021, bringing the total cost to over $400 billion. Ultimately, the F-35 is a testament to the complexities of modern military technology. While it represents a major leap forward in terms of stealth and versatility, its development has revealed significant flaws in the way the U.S. military approaches large-scale weapons programs. The combination of political interference, technological innovation, and the sheer scale of these programs has resulted in massive costs that may take decades to fully understand. In the end, while the U.S. military's investments in next-generation war machines like the USS Gerald R. Ford and the F-35 may ensure technological superiority for years to come, they also serve as cautionary tales about the hidden costs of innovation. As these machines continue to evolve, The true cost of maintaining them, both financially and logistically, remains an open question.